Is we're going to be solving trigonomic equations. So we've already done some basic solving of trigonomic equations, but we haven't done them as difficult as the ones that you're going to have for this chapter. So let's just go ahead and review solving trigonomic equations really quick. If I had sine of x equals 0.3. Inverse. How do I solve that?
Inverse.
Yes, I do an inverse. So x equals inverse sine of 0.3. And then we do the inverse sine, and we'll go ahead and be in degree mode.
In this chapter, 17.5.
Okay, 17.5. And then we need to remember that sine is positive in two quadrants, quadrant 1 and quadrant 2. And we'll go ahead and subtract this from 180 to get the quadrant 2 answer. So what's 180 minus 17.5?
162.5.
And that's our other answer. So we have these two answers. We could graph it like we did at the beginning last chapter to get the other answers, but we want to move towards avoiding that if we can. All right, so this is section 14.2, and we're solving trig equations, but these are going to be more difficult than something like that. So let's say we have something like this. 4 tangent of x equals 3 plus tangent of x. In general, now this isn't always going to be the case, but in general, I'm going to want to get all the trig functions to one side. Usually that's what I'm going to want to do. Usually I'm also going to want to avoid dividing by a trig function. Because if I divide by a trig function, I'm going to end up losing some answers. So I want to avoid that if at all possible. We want to watch for factoring. Factoring is fair game. And that said, we also want to watch for roots. Okay, because if we get roots, if we take a root, we have two answers, which is going to add to the number of answers that we have so far. We have the plus version and a minus version. So in this example, our first step would be to get the trig to one side. It seems that the left-hand side would make sense, so I'll subtract the tan x. And 4 minus 1 is 3, so I get 3 tan x. And I divide by 3, and I get a 1. At this step, I can go ahead and do the inverse. So x equals inverse tan of 1. Now remember, we use inverses to get the angle. And when we do the inverse tan of 1, we get what? 45 degrees. Okay? And tangent is also positive in quadrant 3, so I'll add 180 to that to get the quadrant 3 answer and get 225 degrees. Okay?
That's your answer?
Yep. Now, sometimes we have, and I'll do these examples because they're pretty easy. I have cosecant of an angle equals -1. Now, my calculator is not built in with an inverse trig function for cosecant. So when we have cosecant, cotangent, or any of those cofunctions, I need to go ahead, or reciprocal functions, I need to go ahead and switch them. So I'm going to switch cosecant to sine. Now, while I did say over here that we want to avoid dividing by trig functions, it is okay to multiply by them. So I can multiply trig functions on each side. So when I'm over here, I can clear the fraction by multiplying both sides by, yes. And that would distribute to everything, so I get 1 equals negative sine. And then I need this negative to go away, so I multiply both sides by a negative. And now I can do the inverse sine. And my angle equals 270 degrees. And I think that's the only answer. Is that correct? Is that what you got?
Negative 90.
You got negative 90, which is when we
Oh, yeah, there she's.
when we add 360 to get that to be the correct
Okay,
angle.
Kane being on
Okay, so, and there are no repeat answers there, so that's the only one.
Can you slow down a little bit?
Just a little bit. Okay, next one.
You're flying through it. I'm trying to comprehend it.
Okay, I will stop right here and doodle your portrait down here while you catch up.
Oh, I'm caught up. I was just right. You put this on YouTube, don't you?
Yes.
And you put all your doodles on there?
Yes. I can't I'm not going to undo my doodles. This is Jarrett. Everyone who watches this is Jarrett Rich. His address is, his social security number is, please steal his information. And
Just look them up on PlayStation.
Yes, PlayStation
1854.
And no one watches this except NCAA students. A kid from 10 years from now is going to be like,
Over 1,600
Wow.
hours in Destiny.
Mr. Kane is still a mean old grump. Okay. So in this case, I could do sine or cosine over sine, but then I have two trig functions. It's going to be easier to work with one.
What's that caster?
So instead of changing this to cosine over sine, I'll change it to 1 over tangent. I'll clear my fraction, so I'll multiply both sides by tangent.
Who's that? Josh.
Hey, Drew.
Your mom called me that.
Thanks. Not my mom.
Oh, Josh, you don't got no header.
You gotta draw a hat on it.
Mr.
You
Kane,
want
why
to
did you leave the game early yesterday?
Mr. Kane, you were my bad luck charm yesterday.
Huh?
Every time you were
What
in
the
there, I
heck is
messed
that?
up really
You're like
bad.
the Pillsbury Doughboy.
This is baby Josh.
I fell off a
He
counter.
looks like a turtle.
His aunt pushed him off the counter. That explains everything.
Was that big?
Yeah.
And we divide. What do we do next?
Driving everything.
Divide by negative 10.
My dad almost had to catch me when the doctor pulled me out the one.
And now what do we do?
Inverse tan.
All right. So what do we get for our angle?
Negative 5.71. That's what I got.
Okay.
Let me see.
Well, I gotta add, never mind.
Come on.
354.29.
Okay. So tangent is also negative in what other quadrant?
4, 3, 2, 1.
Let's guess them all.
2.
Quadrant 2. Because cosine's positive in quadrant 1, sine's positive, tangent's positive. Cosine's positive in quadrant 2, cosine's negative in quadrant 2, sine is positive. That means tangent is negative in quadrant 2. So how are we going to get the quadrant 2 answer?
Subtract 180.
Well, yes, subtract that from 180.
Yeah. That's what I'm doing.
And what do we get?
Oh. Hold on.
Gosh, Josh.
Boy, we can do the inverses and all this. Subtraction is what gets us.
I need to go back to
185.71.
What, 1?
85.71.
That doesn't make sense.
Why? 174.29. Negative and a negative.
Ah, but this is a reference angle, remember?
174.2.
So if you do what you just did, you went from a quadrant 2 angle to a quadrant 3 angle. So
Good, Josh.
so it's 1.
74.29.
Wow.
Okay, so this is one answer. And this is the other answer. 0 to 360 is the unwritten rule that we're. Okay.
Hey.
All right. Now we're going to get into some of the factoring ones.
Oh, go.
Okay.
Wait.
Okay. Okay.
You need to go see your mother. Josh.
let's say we have sine squared minus 1 equals 0.
You have to add them first.
We could do that.
Or would you square it?
So there are two ways that we could do this. Either one's fine. I like this first way. I see that I can factor it. It's like this. If I had x squared minus 1, I could factor that to x minus 1 times x plus 1. So I could factor this and get sine of theta plus 1 and sine of theta minus 1 equals 0. Now this is only going to work if we have a 0 over there. So we do need to use the 0 property.
I love factoring.
And then we split this up. Sine of theta plus 1 equals 0, or sine of theta minus 1 equals 0. And then we solve both of these. So sine of theta equals negative 1, or sine of theta equals positive 1. And then we inverse sine, and we'll get, we already did one where we had a negative 1, so we get a 270 degrees right there. And on this one, if we do the inverse sine, we're going to get a 90. There are no repeat answers for either one of these, so those are all the answers. Now, you're going to see really quick why I prefer this way over the other way. Josh had suggested, well, we could add the 1, and that's true. I could do sine squared theta equals 1, and then to undo a squared, what do? Square root it. So if I take the square root though, so I'm going to root both sides, I need to remember that I get two answers. I get a negative 1 and I also get a positive 1. Whenever you take a root as part of solving an equation, you need to account for both the possibilities. And then we inverse sine both of those and we get the same answers, 270 and 90 degrees.
So if that was like a, like after the equal sign was a 1, you couldn't do the first thing?
Oh, if this were something other than 0?
Mm-hmm.
You would have to get that other thing to the other side, which actually is going to happen in our next example. So I'll wait a moment for you to get this down.
Can you draw a doodle with someone else?
Oh, you?
Bless you.
It's got a
If that's
square.
me, I'm gonna be mad.
It's got a square head. He's Grant.
What is that?
A cigar.
It's ice cream.
It's ice cream. Yes, it's ice cream or the cream puff. he's got some.
Dude, he's got a Chinese.
He's got like some all over him, and he's sad because he's been called the cream puff.
Girl,
What?
you think I close your window?
Yeah,
This
what's
is
your-
Cambo. Hashtag Cambo. Okay, going on. Going on. 2 sine squared theta minus 3 sine theta equals 2. Now, before we do this one,
Oh man.
if I had 2x squared minus 3x equals 2.
Subtract 2.
Yeah, we would subtract the 2,
And factor.
then factor. So let's go ahead and do that. Let's factor this.
2x and x.
2x and x.
You only do 2.
Now I have a negative here, so negative,
Plus,
positive. I need, I'm going to need a negative 3, so I'm going to have a negative 2 right here. That'll give me a negative 4, and then plus a 1 right here, plus 1. So when I do my check, that's negative 4x plus x is negative 3x, so that checks. Okay, always check your factoring. It would be sad to get something wrong because we factored it wrong. Then we would do what? 2x plus 1 equals,
0.
and x minus 2 equals 0. So we,
Get negative 1 half.
and we get x equals 2. So when we get up here, even though these are trig functions, they're going to treat it exactly like this. So what do I do first?
Factor.
Not yet.
The 2.
Subtract the 2. I need a what over here?
0.
Yeah, I need a 0.
Oh.
Now, when do I need to worry about that? If I have squares, I'm going to need to worry about that. So 2 sine squared theta minus 3 sine theta minus 2 equals 0. And now we factor that. And we factor it just like we factored this. It's just a little bit longer to write because we have to write 3 letters. Heaven forbid that we write 3 letters, sine, and minus 2. plus 1. Exactly the same situation as over here. So if you can recognize that, that's good. And then we have split this into two parts. 2 sine theta plus 1 equals 0. And sine of theta minus 2 equals 0. We
Hold on,
add
where
the
did
2.
the 1 come from? Where did the 3 go?
What?
There's ain't a 3 anymore, and there's a 1. Where did it come from?
Where did they go?
That we factored.
No, the other side.
No.
Right there.
You see it? Look over. See that? Minus 3?
right, down,
Damn,
down,
minus
right
3.
there.
Where'd it go?
We took this
Mm-hmm.
and we factored it.
Oh, no,
Just like we did right here.
Y'all crazy.
We took this, Grant. We took this and we factored it. It didn't like disappear.
Yeah, but I thought that 3 was with the sign.
I see,
minus
because the
2.
first one is squared, the second one's not, so it's the same thing. Oh.
Yes.
Oh.
Sorry for you.
Do you see? This is like an x squared. This is like an x. So I factored it.
Okay.
Okay. Now, at this point, we're going to go ahead and solve it just like before. We divide by 2, so we have sine theta equals negative a half. Now, if I inverse sine this one with a 2, we should remember that sine and cosine are limited. They have to span between negative 1 and 1. So I can go ahead and reject this as a possibility. That's not going to work. So over here, I do the inverse sine, and I get what?
Negative 30.
Negative 30. Okay, which when we add 360, we get 330. So our reference angle is 30 degrees. Now here, sine is negative, so that's quadrant 4, and quadrant, which other quadrant is sine negative?
2. Wait.
1.
1. No, 3.
Can we guess wrong like a million times?
Yes.
Sine has to do with y values. Where are y values
3
negative?
and 4.
3 and 4, y values are negative. So we need our third, we have our fourth quadrant answer, we need our third quadrant answer. So that would be 180 degrees plus our reference angle. Our reference angle is 30, so that would be 210. Okay, those are our two answers. And if you get stuck at that at this point, or even at this point right here, you could graph that and do the y1 is this stuff, the y2 is 0, see where they intersect, and get all your answers and double check it that way. I'm going to do one more recorded example, and then I think we will get some practice then.
Can I tell you a story when you get done recording
Sure.
about my bad luck in Destiny?
Sure, why not? All right, here is pretty much as hard as it's going to get. Well, maybe we'll do one more example after this. So 2 sine squared theta plus cosine theta minus 1 equals 0. Now, this would be like having something like this. It would be like this: 2 sine, or 2x squared plus y minus 1 equals 0. And we're not going to be able to factor that. Why? Why? Because this is a sine and this is a cosine. Those are two different things. So I need to change into all one trig function. And that's where our Pythagorean identities are going to help us. We have this Pythagorean identity: sine squared theta plus cosine squared theta equals 1. And I have a cosine here. I'm not going to be able to change this cosine because it's not squared. But I can change the sine squared. So sine squared equals 1 minus cosine squared from this formula. So if I replace that, I have 1 minus cosine squared theta plus cosine theta minus 1. I distribute this 2. Now I can't combine these because they're not like terms. So I'm going to just get everything to the right-hand side because this is negative. That's going to be harder to factor. We want our highest power to be positive. So we will get everything to the right-hand side. So 0 equals.
Why is there 2 minus 2?
You distribute.
I distributed right here. I replaced sine squared
never mind.
with this, and then I distributed the 2. So now I'm going to add this to the other side. I will subtract this to the other side. And now 2 minus 1 is 1, so then I'll subtract that to the other side. Now I'm going to attempt to factor that. So when I go to factor that, it's kind of like having 2x squared minus x minus 1 equals 0. And I can factor that. It'd be like 2x, x, minus 1 plus 1. It would factor like that. So I'll factor this. 2 cosine theta. Cosine theta. Minus a 1. Plus a 1. Now, either this equals 0 or this one equals 0. Let's deal with this one. It's a little bit easier. I'll add the 1. And when I do the inverse cosine of 0, I should get 90. Is that what you get? Inverse cosine of 0?
Yeah.
Okay. I am going to have a repeat answer with that. Cosine is also 0 at 270 degrees. Okay. Now, if you can't figure that out, you can go ahead and use your calculator to help you figure that out. This one, we'll subtract the 1. We'll divide by 2. We do the inverse cosine of this, and what do we get? Okay, 120. So where else is cosine a negative half? Well, now think about it before you call out wrong answers. Where is cosine negative? Cosine has to do with negative values.
2.
Or it has to do with x values. So quadrant 2, x's are negative, and quadrant 3. So my reference angle is not 120. My reference angle is actually a 60. So I'm going to do 180 plus the 60. 240. Now, just to clarify where we get that reference angle of 60, if this is my angle and this is 120 degrees, then this in here would have to be 60 degrees. So
How come on the right side, where'd the 1 go when you added it?
What one?
Look at it right there.
Oh, am I a dumb butt? I'm a dumb butt. Yes. This is wrong. So our other answers over there were wrong. We should have added the 1. We do the inverse cosine of 1. And the inverse cosine of 1 should give me 0 degrees. And that should be the only answer. I mean, 360 is also a possibility, but we don't need that one. That's the same as 0. All right, so those are 3 answers to that one. One more, just for fun. Do you want one like this, where we had to change one of the trig functions? Or one that's more tricky to factor?
How did you change it? Oh, never mind.
All right, let's do one where we have to change it. Let's say we have 2 cosine squared theta plus sine of theta equals 1. I have 2 different types of trig functions. Which one can I change? The cosine. Why can I change that one and not the sine?
Because there's not squared.
Yeah, the sine is not squared. The cosine is squared. How do I change it? Well, I have this Pythagorean identity, right? And if I want to change cosine to sine, solve for sine. So I subtract the cosine, and sine equals 1, that. Now, I have cosine, did I do that backwards? I want to change the cosine, so I solve for cosine squared. So cosine squared equals 1 minus sine squared. Get everything into sines. Someone mentioned taking a square root. See, this is a cosine squared. So I've solved for cosine squared. So I'm going to take this as it is and put it into here. Because this is a cosine squared, so I solved for cosine squared. So I don't need to do any square roots or anything like that. And I don't want to do that, because then I get 2 answers. And I don't want to have to account for that. Now what do we do?
Subtract it on 1.
Yep. And distribute the 2. And we can go ahead and combine and put everything in order. So a -1 plus a 2 is a 1. I'll get everything to the right, or I could multiply everything by -1. So I'll just switch all the signs by multiplying by -1, both sides. A 0 times a negative makes no difference. So I changed all the signs of the sign. Okay. Factor this. 2 sine theta. Our only choice is with a 1 or a 1. So I need a negative here. So this one negative, because that'll give me a -2 and plus a 1. Now I solve both of those. Divide by 2. And inverse sine this. Now this is negative. Think which quadrants is sine, that is the y value is negative.
2 and 3. No, sorry. 3 and 4.
3 and 4.
Alright.
3 and 4. Alright, so we inverse sine -1/2. And what's inverse sine of -1/2?
Inverse sine of -1/2
Yeah, Miss Pam.
would be positive, wouldn't it?
That's a nice guess. Can I help you?
I hope so.
Okay.
Since you put that other tower in my room, I can't print.
I can fix that for you.
Thank you.
I will do that shortly.
And evidently my, the one on the stand has lost its way because I tried to print from it, but it gives me all the options and everything, but it never gets on.
Okay.
So I was trying to do it on the other one.
Have you gone crazy and pulled out cords and things again?
No.
Okay. So there's a mess back there.
I throw them and,
All right.
when they won't pay attention, I take off the cords and stuff. Ask Josh, he knows.
Oh, well, we have a confession on video that's going on YouTube. Miss Pam uses computer cords.
Oh, is this on YouTube?
It will be.
Please come visit me in the jailhouse. I like chocolate cake.
Put a knife in it.
A file.
A file, please. A file, okay.
-30.
-30.
Which is 330.
And then we add and we get 330. Now we need so our reference equals 30. We need the quadrant 3 answer. So yes, 210. Good job.
That's a
Okay, that's that one. This one. I'll go ahead and add the one. I added that one to the other side. Inverse sine, and we get 90. And that's the only answer for that. So those are our answers. Okay? Alright, that is good enough.
Oh, wait. Okay.
I'm